Hello everyone. Let's continue solving problems from Friday, week 12, in-class exercises number 3. The question is, what is the maximum vertical distance between the line y equals x plus 6 and the parabola y equals x squared from -2 to 3? The numbers in red might be different with yours, but the process of solving the problem will be exactly the same. So stay tuned and let it begin. First, I'm going to show you the steps to solve an optimization problem. In fact, this is an optimization problem because we're trying to find the maximum of a function. Step number 1. We first have to read and understand the problem, and once we have understood the problem, sketch a diagram so that we can find an objective function in step 3. This objective function is the function that we need to maximize or minimize. Step 4. Find the domain of the function. And finally, we use either first derivative or second derivative test to figure out the absolute maxima or minima. So our goal for this question is we want to find out the maximum vertical distance between this line and this parabola from -2 to 3. Okay, so step 1, we read the problem, understood the problem. In step 2, sketch the situation. Let it begin. If you look at this interval, we have to start from x equal to -2 up to 3, right? So plug -2 into the x. Our y value becomes 4. Let's say somewhere here, the start of the line starts from here. If you put 3 plus 6 becomes 9. So this is the line y equals x plus 6. Now, this is a parabola with a vertex at 0, 0 and -2, 4. Like this. And then, if you plug 3 into the x, you get 9. So at this position, this is where the two functions meet with each other. And our goal is to find out the maximum, the vertical distance between those two functions. So let me give you choices. Look at my vertical bar. Do you think this vertical bar, number 1, is longer than this vertical bar, number 2? Yes or no? If you said no, then you're correct. This vertical distance is so small compared to our second vertical distance. So you have a feeling that, whoa, we need to find out this special x value so that we can find the maximum vertical distance between the top function and then the bottom function. Here comes my hot and spicy tip. Did you just hear what I said? I said the vertical distance between the two functions is called the difference. The difference is the top minus the bottom. Please keep this in mind. The difference is top minus bottom. We're going to use that very soon. Anyways, everyone, this is the end of step number 2, sketching a diagram. Step 3 is to find out an objective function for this one. The objective function is top minus bottom. Stay tuned. Step 3, we need to find an objective function which we need to maximize. Here's hot and spicy tip. Top minus bottom is the function that we're going to maximize. Let's call the difference function is capital D of x. Capital D of x is top minus bottom, which means x plus 6 take away x squared. Top minus bottom is the difference function now. We are done with the step 3. Step 4, find the domain. The domain is so easy in this case because we're looking at the minimum x value of -2 and then the maximum x value of 3. This is our domain. Step 5, let's take the derivative and find the critical number and find out the absolute maximum. We're going to use either first or second derivative test to find out absolute maximum. In fact, you guys know that the first derivative or second derivative only tells you about local minimum or local maximum. We can use the table of values to find out absolute maximum. So that's what we're going to do. Take the derivative first. Derivative of x is 1. Derivative of 6 is 0. Derivative of x squared is 2x. This means the critical number is 1/2. And because our domain looks like -2 to 3, the number line looks like something like this, everyone. And then you can find any number in between -2 and 1/2 and show that this function is increasing. And then you can plug any number in between 1/2, 3 into the derivative and show that this is decreasing. And did you see that, everyone? Increasing and decreasing means 1/2 is a local max. But you know, we're not interested in finding the local max. We're trying to find out the absolute maximum. For the closed interval domain, feel free to use a table of values. Like this, everyone. And then put the endpoints, -2 and 3. And in between these two endpoints, we plug the critical number, 1/2. Plug these numbers into our original d of x, and our corresponding y values become 0 and 0. As you can see, this difference is 0 here because they meet with each other. The difference between the two functions is 0 here because they meet with each other. In fact, 1/2 was the right answer because the y value is 25/4 more than 0. Do you understand? Do you know what this means? The maximum vertical distance between the two functions on this interval is 25/4. That's what it means. Thank you so much, everyone. This is the end of number 3. Let's move on to the last question, number 4.